All right, folks, in this video we're going to look at some more applications of derivatives. Mainly we're going to focus today on rectilinear motion, which are problems that involve position or displacement and velocity and acceleration. And the long and short is the first derivative of the position function is the velocity function, and the second derivative is the acceleration function. Okay? One thing to note is that we often use s at t to represent displacement, or could say x at t. But as I said earlier, here, and notice they're using Leibniz notation. Okay, the velocity is equal to the derivative of s with respect to time. So we can say that s prime t, in this case, let's take the derivative. What would the first derivative of this be? Well, 8t to the first plus 7, a simple power rule. And now I have an equation for finding the velocity. A lot of times you'll see people just, instead of writing s prime t, they'll write v. The velocity is equal to 8t plus 7. And next couple problems we'll work on displacement and velocity, but then after that we get into something called acceleration. Acceleration is really just the second derivative with respect to time. So 8t would be 8. Okay? And instead of calling it s double prime t, we can think of it as acceleration. Okay, so again, the original function is a position function or displacement. And these problems, you'll see things like particles moving or stones being thrown off a cliff and certain things like that. But the original function might say h at t or x at t, h for height, s for displacement, but that represents position. First derivative represents velocity, second derivative represents acceleration. All right, let's look at a few problems. So if a stone is dropped from a cliff that is 122.5 meters high, and its height in meters after t seconds is given by the following function. H equals 122.5 minus 4.9 t squared. Find its velocity. Well, remember the velocity is the first derivative. Okay? So here we have it. H equals 122.5 minus 4.9 t squared. H prime, or v, is going to equal the derivative of a constant, 122.5 would be 0. The derivative of negative 4.9 t squared would be negative 9.8 t. All right. Now they want to know the velocity after 1 second. So I am going to take this and I'm going to fill in 1 in. A 1 in for t. And I get a velocity of negative 9.8. And our units would be meters per second for velocity. They also want to know the velocity after 2 seconds, I believe. So I'm just filling a 2 in for t in this case, and I get negative 19.6 meters per second. Okay, in terms of like the negative, what that means, okay, it's direction. Velocity is speed with direction. So a lot of this stuff overlaps with physics. Okay, in this case, it indicates that the ball is going down, or if it was positive, it would indicate the ball being thrown into the air. When we're talking about particles moving, okay, positive goes to the right, positive velocity, or in terms of the stone being thrown upward, and negative velocity would refer to the stone falling downward, the particle moving left or the stone coming down in this case. Part B, when will the stone hit the ground? Okay, well think about that for a second. When will the stone hit the ground? We have these two formulas. We've got one that tells us the height of the stone and one that calculates the velocity of the stone. When the stone hits the ground, think of what the height will be. Well, in this particular case, it hits the ground, the height will be 0. So for part B, I take the height equation, or the position equation, and I'm going to fill a 0 in for h, and then I solve. Now, you could solve this a couple ways. You could factor difference of squares, or you could bring the negative 4.9 t squared to the right, add negative 4.9 t squared to both sides. You're left with this. Then you divide both sides by 4.9. Okay. You'd have t squared equals 25. All right. And then take the square root of both sides, and we end up with t equal to plus or minus 5. Now, in this particular question, it didn't give us the constraint, okay? But a lot of times they tell us with these, you'll see this. Okay, especially when we're talking about time. Time is, we usually think of time as being positive, not getting into negative time. It doesn't always show that, okay? But if it does for sure, then we would choose a positive time. 5 seconds. So to answer the question, when will the stone hit the ground? I would say the stone will hit the ground in 5 seconds. Part C, with what velocity will the stone hit the ground? So for part C, I know it hits the ground in 5 seconds, so I'm just going to calculate the velocity at 5 seconds. So I plug a 5 in for t. So again, I went back to the velocity function. Negative 9.8 times 5, that's 45 and 4. That gives me negative 49. And remember the units again, meters per second. Okay, so there's a quick problem involving position and velocity. Just remember, if the stone's hitting the ground, height would be 0, and then you solve. You can solve this to quadratic, so you could have solved that the way I did. You could have factored it using the difference of squares, or you could have used your quadratic formula. Another example, the position of a particle moving on a line is given by the equation S. Okay, S represents displacement, equals 2t cubed minus 21t squared plus 60t, where t is measured in seconds and s is measured in meters. So again, we're talking meters in seconds. So velocity would be in meters per second. Find its velocity after 3 seconds and 6 seconds. So for part A, I want to take the position function or the displacement function. If I want the velocity equation, I take the derivative of this. V equals 6t squared minus 42t plus 60. All right, that's a pretty simple derivative. That's one that we learned back in pre-cal B using just the sum and difference rule. It's a power rule with more than one term. Find the velocity after 3 seconds and 6 seconds. Okay, so to find the velocity after 3 seconds, I am going to go 6 times 3 squared minus 42 times 3 plus 60. This gives me 9 times 6, that's 54. That's 120 and 6 minus 126 plus 60. Okay, that's 114 minus 126. Okay, V is going to equal negative 12 meters per second. You guys can check that. I think I'm good there. 9, 54, 6, and 60. And it looks good. So that's after 3 seconds. after 6 seconds, 6 times 6 squared minus 42 times 6 plus 60. 6 cubed, 6 squared, 36 times 6, that's 216. That gives me 240 and 12, so that's 252 plus 60. 216 and 60 is 276 minus 252. And that gives me 24 meters per second. Now again, a negative velocity, we can assume this is moving, particle's moving left. Didn't ask for that, but that's what it means. And this is a positive velocity, indicates the particle is now moving right. So a lot of times, or if they ever ask you to draw these, you'll see that the particle may go like to the right and then to the left and then back to the right. This kind of thing. What else we got? When is the particle at rest? Okay. So when the particle at rest, this is where we set the velocity equal to 0. If the velocity is not moving, or velocity is 0, it means it's not moving. It's not moving left or it's not moving right. Okay? It's not moving at all. So I'm going to take that velocity equation. V equals, and I believe it was 6t squared minus 42 times t plus 60. Double check that. 6t squared minus 42t plus 60, yeah. And I'm going to set v equal to 0, and I'm going to solve for t. So to do that, I'll factor out a 6 first. Okay? Then I have a simple trinomial in here. Two numbers that add to give -7 and multiply to give 10. That would be t minus 2 and t minus 5. Okay, you can see t times t is t squared. This times this is -5t. Inside, that gives you -2t plus 10. -5t minus 2t is your -7t. So this is the factored form of that. Now, the only way you can multiply these three things together and get an answer of 0 is if one of the factors is 0. Well, this is not going to be 0. 6 is 6. It can't equal 0. But t minus 2 could equal 0, or t minus 5 could equal 0. And there we have our times. That answers when. If they ask you when, that's like they're asking for the time. So what are the units on the time here? Seconds. So the particle would be at rest 2 seconds and at 5 seconds. Okay. I believe that's it, only part A and B. The next little bit is where we get into acceleration. Okay, the acceleration function is the derivative of the velocity function. Okay, well, if the velocity function is the derivative of the position function, and the acceleration is the derivative of velocity, we can infer that acceleration is the second derivative of the position function. Okay, so it kind of looks like this. If you have h at t equal to height, h prime t is the velocity, h double prime t is the acceleration. Leibniz notation looks like this. Acceleration is the second derivative of position with respect to time. Okay? So here's a couple of questions. These ones have some acceleration. So the position function of a particle, again we're talking about a particle, is s equal to t cubed plus 2t squared plus 2t, given by where s is measured in meters and t in seconds. Find the velocity and acceleration as a function of time. So all they're asking you to do in part A is find the equation for velocity and the equation for acceleration. Pretty simple. Velocity is just the first derivative. And acceleration is the second derivative. Okay? Nothing spectacular or tough there. Part B. Find the acceleration at 3 seconds. Acceleration, I know to use this formula. This is the one that's going to give me acceleration. And all I'm doing is plugging this time, 3 seconds, in for t, and I'm solving. A is going to equal 18 plus 4, 22. Now it's meters per second squared. Remember, velocity is meters per second, or it could be feet per second, or kilometers per hour, all right? But acceleration in meters per second squared. And then position is just meters, or just, it's a linear unit. Okay, so there's that one. I believe there's one more to bang through, and then you guys can go to work on some questions. It says a ball is thrown upward with an initial velocity of 24.5 meters. Notice how it's positive. It's going upward. Okay. Then its distance above the ground in meters after t seconds is s, the position. Okay. They might use h or h at t, but s represents position. Equals 24.5 minus 4.9 t squared. Find the acceleration of the ball. So if s equals 24.5 minus 4.9 t squared, and any of you who've taken physics, you've probably talked about all of this stuff before. Velocity function would be negative 9.8 t. Derivative of that would be 0. Derivative of this would be negative 9.8 t. The acceleration is just straight up negative 9.8. Okay, and we could say it's meters per second squared. This is called a constant acceleration. And again, we'll lean on you physics students. All right, anyone know what causes this constant acceleration, negative 9.8 meters per second squared? That is known as the acceleration due to gravity. Okay, the fact that it is negative means the ball slows down as it rises and speeds up as it falls. In general, a negative acceleration indicates that velocity is decreasing, and a positive acceleration means that velocity is increasing. So, that's it for rectilinear motion. You can try these questions on page 125 and 129. Okay, if you have any questions, just let me know.